Unit 4 Review, Problem 2. The results of a nationwide Gallup poll concerning a person's race and their opinion on the death penalty are summarized in the table below. Part A asks, is a person's opinion on the death penalty independent of their race at the 1% level of significance? So here, this question is asking whether these events are independent of each other. Statistically, to decide whether two events are independent of each other, we can use the chi-square test for independence to make this decision, because the chi-square test for independence is used whenever we want to determine whether two events are independent of one another. So we can use the following steps when conducting our chi-square test for independence. Starting with the first step of any hypothesis test procedure is to state the hypotheses, HO and H1. In the chi-squared test for independence, HO, the null hypothesis, is always the same. HO is that the events are independent. And H1 is always the same, the opposite, that the events are not independent. So now that we've explicitly stated the null and alternative hypothesis here, that the events are independent for HO and that the events are not independent for H1, we can go to step 2 of our hypothesis test procedure, which is where we identify alpha, the level of significance to be used. It is customary in any hypothesis test procedure to use alpha equals 0.05 or 5%, unless stated otherwise. In this problem, it's specifically stated to test this result at the 1% level of significance. So we'll use an alpha equals 1% or 0.01 decimal. Now with the level of significance stated, we can go to the third step, where we use our sample data results to calculate a p-value, which can then be used to reach our decision and state a conclusion. In a chi-square test for independence, the data is organized in table form, where one of the variables is expressed across the rows and the second variable is expressed down the columns. So these observed frequencies or sample data need to be entered into the TI-8384 calculator before we can calculate the p-value. The TI-8384 calculator expresses these tables in a matrix. So to enter this sample data into a matrix, we need to press second, matrix, arrow over to the edit menu, and pressing enter will accept matrix A as the default. Before we enter in the actual observed frequencies or sample data into the matrix, we have to tell the calculator the dimensions or size of our matrix. That is, we have to tell the calculator how many rows and how many columns the data in our table displays. In this problem, the rows, which are represented by the person either being in favor or opposed to the death penalty, has 2 rows. So we enter in 2, enter. The second number, the number of columns in this table, refers to the second variable, in this case a person's race, which was expressed as 3 different categories: white, black, and Hispanic. So then we enter in 3, enter. Now that we have our matrix set up as a 2 by 3 matrix to represent the 2 numbers down and the 3 numbers across in our table, we could then enter in the data values in this table into the matrix in our calculator. The blinking cursor always begins at the upper left-hand corner of the table. We enter in the data from the top row down, working left to right across the rows. So the first data value we enter is the 925, enter. And then 277, enter. And then 394, enter. With the first row entered, the calculator then takes us to the second row. Again, entering the data from left to right, we type in 362, enter, 415, enter, and 317. Enter. Now that we have all the data in our table entered into the matrix in our calculator, we can then go to the chi-square test command to calculate the p-value. To get to the chi-square test command, we press Stat, arrow over to the Test menu, and then we arrow up till we reach the chi-square test command and press Enter. In the chi-square test command, you're presented with the observed and the expected matrices. Again, by putting the observed frequencies into the default matrix A, we don't have to change anything in the calculator. Just accept the default. The observed is in matrix A. Enter. The expected values, by default, are entered into matrix B. So there's no need to change the expected from matrix B. Just accept the default by pressing Enter. So on this chi-square test command screen, you could just press Enter to accept the default for observed matrix A, Enter to accept the default expected matrix B, and the blinking cursor then goes down to Calculate. And with the blinking cursor on Calculate, you just press Enter, and the calculator will calculate the p-value we can then use to make our decision. Once we have the p-value, we can reach our decision and then state our conclusion. In all hypothesis test procedures, the decision is the same. We either reject the null hypothesis, HO, when the p-value that the calculator gives us is less than or equal to alpha, the level of significance. Otherwise, if it's not, that is, if the p-value is bigger than alpha, the level of significance, we do not reject HO. Once we have this decision that we either reject HO or do not reject HO, the final step of the hypothesis test procedure is to then interpret that result. That is, interpret what reject or not reject HO means in context of this problem. And then we need to make sure that we answer the specific question that's being asked of us in words of the problem. So again, once we go through and press Enter under Calculate, the calculator displays calculations, including the p-value. The p-value is the one that's represented by the p equals. In this case, p equals 3.973993 e minus 43. The e minus 43 means that the decimal place the calculator displays between the 3 and the 9 really needs to be moved 43 places in the negative or to the left. And all those blank decimal spaces need to be entered in with zeros. Now, p-values being probabilities, we only need to round off to 3 places after the decimals. So once we get past the 0.000, we could just stop and round it off. So here, this p-value is so small, it's essentially rounds off to 0. Now that we have our p-value, we can compare it to alpha, the level of significance, to reach our decision. Since the p-value of 0.00 is 0.01 or less, the decision is to reject HO. And when we reject HO, the conclusion is the idea expressed in HO is not valid. In this case, HO states that the events are independent. And based on our sample evidence, we're saying that this idea that the events are independent is not valid. So therefore, we should not conclude that the events are independent. And when HO is shown to be not valid, the alternative, H1, is the one that the data supports or indicates is valid. So here, our answer could be that H1 is valid, that the events are not independent. So now we could answer part A. Is a person's opinion on the death penalty independent of the race at the 1% level of significance? The answer is no. Therefore, a person's opinion on the death penalty is not independent of the race at the 1% level of significance. Now that we've answered part A and shown all our work, we can move to part B, a follow-up question. Part B asks, based on these results, What can one conclude about the relationship between a person's race and their opinion on the death penalty? Well, the results we observed in part A was that the person's opinion on the death penalty is not independent of their race. And when two events are not independent of each other, that means they depend on one another. So whenever two events depend on each other, there is a relationship. So here we could respond to part B by saying, based on these results, one can conclude that a person's opinion on the death penalty is related to their race. Now, the hypothesis test just allows us to answer either yes or no. In this case, no, they're not independent. Therefore, there is some sort of relationship. In order to get more insight into the actual nature of the relationship, we need to look inside the data. So if you look inside the table or the matrix, you can see that for the whites, there were significantly more that were in favor of the death penalty, 925, than there were who were opposed, 362. And so since those that were in favor, the 925, was much more than those opposed, 362, we can say that whites were much more likely to be in favor of the death penalty. With Hispanics, we see the same sort of trend, but it's not as significant or as large as that for whites. With Hispanics, the number that were in favor, 394, is higher than that who were opposed, 317. So we could say that Hispanics are more likely to be in favor of the death penalty than opposed, but this is only just slightly more in favor. So even though Hispanics and whites show the same trend, whites were much more in favor. Hispanics were just slightly more in favor. But looking at the sample results for blacks, the trend is the opposite. 277 of the blacks were in favor of the death penalty, whereas 415 were opposed. Here, many more blacks were opposed to the death penalty than were in favor of it. Here we get the opposite trend. Blacks are much less likely to be in favor of the death penalty. So to answer part B, there's lots of different ways you can respond to this question correctly. You just need to describe the relationship that's seen here. In this case, since part A says they're not independent means they depend on each other. That gives us a conclusion that there's definitely some relationship here. So that's why we said, based on these results, one can conclude that a person's opinion on the death penalty is related to their race. But to get some insight beyond that there's just a relationship, you need to look inside the data. And here you could see that the trend differs for the different races. And then describing those in whichever way you seem appropriate will help describe the relationship. In this case, we describe this relationship as that the data indicate that both whites and Hispanics are more likely to be in favor of the death penalty, whereas blacks are less likely to be in favor of the death penalty.